Rob and Matt, just as an introduction, are my bosses, and they basically signed me up for this and said, figure out a way to tell people about the good and bad ways that we've put our research to use. And so that's where we are right now in our day-to-day lives. We're basically in a cycle of doing research and trying to get it into production and often failing. And basically for us, it's where we step out into the road. Where do we go into traffic? When do we start playing Frogger, basically, with the various pitfalls of research and productionizing. So, I thought that I'd just talk briefly about what I mean by research, because it can mean so many different things to so many different people. So I'll pin it down, and I'll say that we're gonna do research, and it's the process of systematically investigating new approaches, maybe not completely new, maybe somebody else has posited them or what have you, but actually investigating if they work for you, for making the fundamental technical problems of a stable business more tractable. And that can mean cheaper or faster or better, or maybe it just is simply making those problems solvable at all. And so, for instance, at AK, where I work, we research all kinds of stuff. We're sketching set expressions on our users, which is hyperlog, and we love that to death, and it mostly solved the problem for us, though we're always looking for better, faster, smaller. How many users saw how many ads, a histogram, and that's something that in Sketch, for instance, we've looked into as a possible solution. Or, how do we fit a bunch of stuff in memory or in a hot memory? And we look into non-cryptographic hashing, murmur3 and SIP hash and city hash and stuff like that. And those are all things that we have spent either a month on or 10 months on or 3 years on. I mean, the set sketching problem has been around for years and years and years before I even joined the company. So over this period of years of doing research and repeating it and kind of being self-aware and recording what we did right and what we did wrong, we came up with a little bit of a game plan, a way of keeping ourselves honest. And so how do you do research? Well, you read something, you test it, you release it, you peel out, you get out of town, you do another problem, right? And each of those steps has a couple of subtleties, and I'll get into them. But the first thing I want to do is when I say you read a paper, you're reading an academic paper. And just as a little digression, I usually take it for granted that everybody can do this, and that may be true eventually, and I believe everybody can get there. But the first few times are daunting, so I wanted to go through a little primer on how to do that. And just remember those three things I have out there. You can always tackle it in pieces. Read the end first, then read the middle, then read the beginning, and then take little chunks here and there. Do it out of order. This is not the SAT reading exercise. You can do it however you want. You have as much time as you want. Ignore the proof the first time through. You're just, if you're new to this stuff, you're not going to get it. And that was how it was for me. I read hyperlog, and I'm looking at a proof that has the melon transform and complex space, and it's just like I'm sitting there like, oh my god, I know I'm a math major, but this is killing me. So ignore the proof. You'll get back to it. It's not an issue. It'll give you more insight when you're ready for it. And then finally, the symbols thing. Just go ask your friends. It's impossible to post to Math Overflow, like, what is this symbol? And it's like some crude drawing of something, and it turns out it's like a zeta or something. It's a lowercase zeta in some weird font. So just ask your friends. And then less tactically, when you're reading a paper, it's easy to get lost in the weeds and be stuck on a lemma or a proof or something. So constantly remind yourself what you're doing this in service of. What is this going to deliver? And what will you have to give up in order for it to deliver that? And this leads to the second point, which is that you need to be constantly aware of the hoops you're going to have to jump through to get this from a theory to an application. And what other tools you're going to have to collect, and what other little bits are you going to have to glue together. So for instance, hashing is a great example of this. It's like, assume you have a uniform, a random bit string of infinite length. And it's like, I don't typically keep those on hand. So how do I turn my data into those? Well, it's like, okay, great, get a hash function. You'll probably have what you need. So back to the kind of game plan. We talked about reading an academic paper, and where do you get that? Well, you get it from your academic community, and it turns out amazing, hyper-intelligent people like the speakers we had here think about all kinds of crazy stuff. Like, just They think about stuff that you never would have imagined. And they cover a lot of ground, they do it well, and these are crazy useful ideas. So turn to them if it's in person, if it's on the web. They're actually quite responsive and very helpful about these things. So figure out the keywords you need to search for your topic, and this is often the hardest part, so I'll skip over that. And pick a paper. You read it N times because, well, nobody gets it the first time, and then read it a couple more times. Give it some space, sleep, have a good night's sleep. It'll bring out a lot of the subtleties. But most importantly, understand a paper for what it is. It has context. It has historical context. It has political context. It has intellectual context. And you need all of those in order to judge a paper sensibly. And the objectives of a writer in an academic world are rarely to deliver an algorithm that's directly suitable to production work, right? They're trying to finish their PhD. They're trying to shave off a 0.05 from the exponent of their big O. They're usually trying to make some little incremental improvement in the paper, and the objectives don't always line up with yours, and that's fine. But we take that in stride and we say, great, what can I get out of it? Even with that context. Well, you read the citations, which is invaluable for understanding the pedigree of an idea, and more importantly, get on Google Scholar and read the cited bys. Right? This gives you an idea of the quality of the paper, because if somebody has come out there and said, hey, this paper is totally bunk, or hey, we have one that's like 6 times as fast, check that out. It's going to save you some time. Come back to the paper and understand, again, the pedigree. But if you can skip ahead, why not? Like, it's simple as that. Now, this is kind of tough to say, but like, you basically need to be very honest with yourself and gut check and say, like, am I inventing something for the sake of invention, or am I doing it because I have a business need? And for us, having a fully funded research group means we have to have a P&L in some sense. We have to have profit and loss. We have to understand the price of what we're doing. And so you have to do that gut check and say, is there a use for this? And does this work? It might be cool, but it might just not work for the problem you're after. So file it away, use it later, but just never delude yourself about how cool something is in order simply to build it or whatever, to justify building it. Always have a good reason. So, ostensibly you've picked something and you haven't been too harsh, and you're in the attitude like, oh, I'm going to give this a shot, right? What do you do next? Well, you test it, right? You got to test it. So you build it, or you steal a prototype, like one way or the other. Don't build it with optimizations. Just build the dumbest version you can. Get it out there. And then what you want to do is you want to test it on theoretical or random data. Basically meet the authors on their own turf. Right? They say, if you have uniformly distributed data, then this will work. So you got to test and see if that works. Like, and this is awesome for debugging, because it's really easy to make little data sets with very slight variance if you're generating the data yourself. Then, obviously, once you're there, you got to test it 8 ways from Sunday on your prod data. And the more runs you have across dates, across customers, cut your setup random ways, and then put it in R or Mathematica or SAS or MATLAB and plot it 8 ways from Sunday, right? You want to see how every aspect of it behaves. Once you're kind of done with that, convincing yourself as a technical person that this works, you have to test it on the people that you work with, right? Like Rob and Matt said, like they come back to me and they say, like, do you think we can build this? Or do you think that this is a sensible intellectual idea? And again, make sure that the people around you buy into this, because honestly, building something on your own as the only person who understands it is folly. Like, if you do get hit by a bus, and this actually happens in real life, like everybody jokes about this, but like if you get hit by a bus, you're leaving a huge burden on these people, and there's no reason for that. So always remember, like, involve many people in this process. And again, they will also keep you honest. They will save you from building something that's a solution looking for a question. So always have the business need in mind. And in practice, this is often where the buck stops, right? Like where you fail, basically, because not all research is fruitful. And frankly, we do this all the time. It happens to us a lot. But that's part of the process. Like, we've institutionalized failure. We've found a way to make it productive. We write about it, whatever. We learn. Keep it in mind for the future. Revisit it sometime. But don't be discouraged. But let's say you've gotten past that point, right? And you're on to releasing. And this is a bit controversial, but I pretty strongly believe you can't deploy prototypes. And so what I do is I tar up the directory with all my test runs, and I put it away in a safe place, and I write myself a journal note, like, today, journal, I finished researching blah. And then I pop up an Eclipse, and I sit there and I write a lot of Java, right? and it's all with that different mindset. I take a nap, I wake up, I'm like in my prod mindset, and I build prod stuff. And then you deploy it and you test it, like for a couple of days on its own in prod, and then you realize like, okay, it's great, it's stable, blah blah blah. And this is where a lot of people stop and just decide that that's enough, and they go on to the next problem, and that's totally fine. But we believe that writing about research and fostering a community around it of implementers and researchers is super important, and it's been a fundamental part of the research process. And honestly, like, why would we have the conference if we didn't believe that? So I'll leave that to you. But obviously the advantages there are that if you have to explain something, like writing about stuff is great, because if you have to explain it to somebody else, your understanding and your knowledge deepens. I think everybody can take that for granted. And if your writing is engaging to boot, you suddenly have a whole group of people who are going to bang on this and who are going to respond and throw their intellects at it. And more importantly, down the line, when you get that community of people you've engaged, they're going to cheer you on, and they're going to help you through the tough times. They're going to throw you a bone. They'll say, hey, I found this paper. Let's talk about it. And the last thing about writing and building community is if you kind of build this shared resource that you can turn back to. I can't tell you how many times that I wrote a blog post, and like 3 months later, I'm like, oh crap, I totally don't remember what this particular trade-off was. And like, look, I can just go on the blog and read it because I was honest about what my results were, and that's what it was. Like, that's my understanding. It's out there in the world. And that actually saves us all the time. Like, I did performance testing on our main aggregation infrastructure, and holy crap, was it useful to just have that in a nice form, because I had to present it nicely. So in the future, I could use that nicely presented form. So that's the formula, right? Ostensibly, you're done if you've gone through this list, and maybe you've done some extra credit, you've written and you've built a community. But if you've done some research and you've built something, you think you've changed the game, what do? Like, you think you've moved to a place where it's more efficient and it's faster, and people really should be using this. Well, you can take that extra step, and you can try to make it the norm, right? And this is a big move, and it's not about production at all, right? It's about the beyond. And I think that a crucial part of innovation is not just building the stuff, right? You take a nascent idea and you make it the status quo. That's the full loop, right? And that's what I think we should all aspire to do. Like, we're here because we believe in a lot of ways that sketching and streaming is amazing, and it really does change things. It changes the fundamental costs of doing big data analytics. And so we're trying to make it the norm. Like, this is why we have this conference. We want to talk to more people. We want to make it more available. Another great example that, I don't count us nearly up in that category, is AWS. Like, they believed in SOA, and so they built a huge product around it, and then they sold it to everybody, and then they just kept on pushing. And that's really impressive to me. That's inspiring to me. They took an idea that was theory or like trendy, and they really made something out of it, and then they forced everybody to realize how good it was. And so what is the process of doing that? What is the process of going from like, hey, we have like a little community and we love talking about it, and we love doing research? Well, you use that community. You never do this alone. And I'm not going to give you the standard open source evangelism story, because that's not terribly productive here. But just remember, it's your responsibility to give that community more than just a library. You're here to give them more than just a tool, right? There's an overused quote by Antoine de Saint-Exupéry that goes, if you want to build a ship, don't drum up the men to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. And aside from being like a real tearjerker or whatever, like, why not give them both, right? Every great library that you put out should have an awesome application that uses that library, right? And every blog post you put out with a great idea or with an open source release, like Rob forces us to do for every single thing we do, is like, put a visualization on top of that thing. Let people experience that visceral, like, holy crap, this really works. This is awesome. That's the inspiration you want. That's what you want to put into people. And if you really believe in the value of your research and the work you've done, don't let it rot or languish. Like, you got to remind people, and a great way of doing that is you go out into your community and you talk to people about the process of what you learned. And if that means sitting down and walking them through a paper, great. Like, these are your friends. Like, do that. If that means walking them through what the important citations they should read are, like, let them come to the place where you are naturally. And if they choose something else, that's fine, right? Like, that process of education and of bringing a community around you that's willing to be, evangelist for your ideas is great. Again, I won't go into that. But remember that like we're all humans in this too. So if you save me some time, I'm going to find a way to pay that back to you. And that's how that chain reaction starts. That's how you go from research to production to beyond. So thank you. You can find me on Twitter and GitHub, and come talk to me afterwards.